In this video, we'll be looking at once again rational inequalities. Now the problem with this rational inequality versus the previous rational inequalities that we looked at is that this one doesn't have that equivalence to 1 yet. So we have to go through the steps of making sure that we first get it in some way equivalent to 1. In doing so, that means I'm going to have to subtract this one from this side over to this side. Don't take the x plus 1 and multiply it across like that, because again you're going to lose some information. You don't know if this x plus 1 is positive or if this x plus 1 is negative based on the values we have, and therefore we don't know if this inequality symbol is going to change. So again, there's only one way to do these rational inequalities if they're not already equal to 0. Your first step will always be to subtract all of the terms on one side to the other. Again, subtract all of your terms from one side to the other. So it's going to give me 2x over x plus 1 minus 1 is greater than or equal to 0. So now that we have it equivalent in some way equal to 0, we have to go through the steps of making sure that this is all either one giant polynomial or one giant rational function. In this case, we have a rational term minus a term that is not rational, so I have to force this into something that's going to be rational. In order to do that, I simply just have to find common denominators. Well, the denominator for this side is x plus 1, so I'm going to multiply this thing by x plus 1 both on top and on bottom. So it's going to look like this. I'm going to have 2x over x plus 1 minus 1 times x plus 1 over x plus 1. This is again greater than or equal to 0 still. And then what I'm going to go ahead and do is I'm going to go ahead and simplify as much as possible. Notice that this negative 1 will distribute to all the terms. I'll have 2x over x plus 1. I'm going to change this to a positive so that the 1 becomes negative. So it's plus, and then I'll distribute the negative 1. Again, only the things on top. The bottom never gets those values when I multiply these things together. So it's going to be negative x minus 1 all over x plus 1, still greater than or equal to 0. And finally, I'm going to go ahead and notice that the denominators are the same, so I can make this all one giant fraction. So I have 2x plus a negative x, so minus x minus 1 all over x plus 1, greater than or equal to 0, and therefore I end up with x minus 1 over x plus 1 greater than or equal to 0. And now I can treat this like I treated the more complicated example in the previous video on rational inequalities, where since it's already equivalent in some way to 0, I can set the top equal to 0, I can set the bottom equal to 0, and I can go ahead and solve. So in this case, I have x minus 1 equals to 0, gives me x equals to 1. That particular location, I have to identify the fact that this is an equal sign and it's on top, so this could actually be an equals. And on the bottom, x plus 1, again, I always set the numerator and the denominator equal to 0, but the denominator can never actually be equal. So x can never actually be equal to a negative 1, but it is an important point for the number line test that we're going to set up. So now let's go ahead and set up the number line test. I have my two values of importance, my negative 1 and my positive 1. I'm going to make note again that the negative 1 is an open circle no matter what I do. The top one, the x equals 1, I got to check my inequality, and sure enough, it's got the equal sign in there. With the equal sign in there, I can fill that circle in. I'm going to go ahead and draw the lines below this. Go ahead and draw this over. I have my intervals for my first. I have my test values for my second. And then I have my plug-in values for my third. So my interval values are going to be from negative infinity to negative 1, making sure that I use an open bracket on the negative 1 value, from negative 1 to positive 1 bracket, and from 1 to infinity bracket on the 1. My test values are going to be 0 in the middle. I'll pick the nice one there. Negative 2 over here might as well, and positive 2 over there might as well. When I plug these values in, again, what we should really do is we should really plug them into the original setup here, because what if we made any kind of mistakes throughout this entire problem? This will at least identify in some way that we made some kind of mistake and something doesn't make quite sense. But in this problem, I feel comfortable with my ability to do this work. When I plug in the negative 2, I'll plug it in down here because I trust my math. Again, if you don't trust your math, I would suggest backing up here, plugging it back up here, or again, going through all these steps to make sure that you've done this correct. When I plug in negative 2 minus 1 is a negative, negative 2 plus 1 is a negative, so I have negative divided by negative divided by negative is positive, so that is greater than or equal to 0, and that section should check. Plugging in 0 gives me negative over positive. That's going to be less than or equal to 0. That section doesn't check. And when I plug in 2, I'm going to have, again, once a positive section. And again, this should make sense because none of these factors repeated themselves. If they did repeat themselves, it is possible for the work, not work, to alternate and not necessarily always be exactly alternating like this. So that means that this section should work, this section should work, and my solution set is negative infinity, negative 1, unioned with a positive 1 to infinity, bracket on the positive 1. And that concludes how to do any kind of basic inequality. Again, this one particular case has the situation where it's not already equal to 0. If it's not equal to 0, you have to go through the steps of first subtracting whatever it is over here to the other side. Again, don't solve this. This is the only problem where you don't solve it like its counterpart to equations. You don't solve this by multiplying by the smallest common denominator, the least common denominator. You are actually going to subtract it all over, get it equal to 0 first, and then do your algebraic steps to making it so that it's all one giant fraction on that side. So again, that's how you solve a rational inequality.